All right, this is our last day of notes talking about solving logarithmic equations. So we focused a lot on using logarithms to solve exponential equations, but now we're starting with equations that have logarithms in them. Before we get started, just to remind you about logarithms, remember this is the operation that helps us figure out what exponent um, is part of our answer. So this is saying like log base 4 of 16, the answer is 2 because 4 squared equals 16. So a lot of times people ask me like, what does the log mean again? And it's kind of like saying, um, like a square root is saying what number multiplied by itself is equal to this thing under the square root. And a logarithm is saying, what is the power that I should raise this number to get this answer inside the logarithm? 25 to the what equals 5? Well, we want to square root 25. So that's also known as a power of 1/2. 3 to the what equals 1. The only way to make a non-1 base equal to 1 is to raise it to the 0 power. And e to the what equals e to the third, equals e to the third. Well, the what has to be 3. Another thing that we'll do a lot in this chapter is say, because natural log and base e are inverses of each other, sometimes I'll cross those out and say I'm just left with 3. How do we find domain of a logarithm? So you've got log or natural log of some expression, right? Remember, we can't log negatives and we can't log 0. Why is that? Because you can't raise a number to a power and get it to equal negative anything. That's not possible. And you can't raise a number to a power and get it to equal 0, assuming it's not already 0. Okay, so because we can't log negatives or 0, it means that the expression inside of the logarithm needs to be set greater than 0, and then we solve from there. Okay, so solving log equations. There are basically like 3 types of equations. Our first one is just a single logarithm. Let's take a look at the example and we'll go through these steps. So this is an example of an equation with just one single logarithm. It's right there. So the steps say to isolate the log term. So let's subtract 1 and then divide by 3. Natural log of x equals 3. And then there are a few ways to think about this step. Some people say rewrite in exponential form. I just say base both sides. Like rewrite this so that it's base e to the ln x equals base e to the third power, right? Because this is what we do for our exponentials. If I start you off here, you would say, oh, if this is true, then ln x equals 3. So you're just going backwards. And then what does that do for us? E to the natural log of x, that's one of our log properties that says that's equal to x. And the answer is just x equals e to the third. You could check these answers if you had a calculator. All of this is non-calculator, but if you wanted to kind of verify, the decimal value of e to the third should be the x value where 3 ln x plus 1 intersects with the line y equals 10. Number 2 is also a single logarithm right here. So let's isolate first. 2 log base 3 of 2x equals 4, because I subtracted 5. Divide by 2. Log base 3 of 2x equals 2. Now I'm going to base 3 both sides because this is log base 3. And the property that I used on the previous one only works if you've got the same base here. So 3 to the log base 3 of 2x equals 3 to the second. The 3 to the log base 3 cancels. 2x equals 9, 3 to the second. X equals 9 over 2. Both of my answers so far have been positive. I do need to check for extraneous solutions. You just need to make sure that you're taking the log of a positive expression. So you can't have answers that give you a negative or 0 in there. Number 3 is an example of a 2 logarithm equation with no other terms. So if that's the case, separate the logs so they're on one is on each side of the equation, it's easier, I think, to not deal with negatives. So I'm going to add the log on the other side. So the log base 5 of 5x minus 1 equals the log base 5 of x plus 7. So both of these are log base 5. As long as they're the same base, that means you can use this one-to-one property. If these two logs are equal to each other, then their results must be equal to each other as well. Then we solve for x. And we check that our answer can be plugged back in. So if I put in 2, I get 10 minus 1. So I get log base 5 of 9. You don't have to show me this. I'm just showing you for our notes. If I put 2 into this one, I get log base 5 of 9. Both of those are positive values, right? So this is fine. If my answer were negative 2, I would get no solution because that would give me a log base 5 of negative 11, and that would be a problem. What if we have more than 2 logarithms? So it's usually 2 logarithms on one side and 1 on the other. So this says use properties to condense to either a single logarithm or like a log equals log scenario. So let's take a look at this. These are all natural logs. So I can condense the left side. If I'm adding 2 natural logs together, I can write this as a single logarithm of x minus 2 times 2x minus 3. And the other thing I can do is on the right side, the only little condensed step is to make the number out in front of the log an exponent, because you can't have any constants out in front of your logarithms if you're going to use the one-to-one property. I can FOIL these together a little bit. Natural log of 2x squared, then let's see, it's going to be minus 3x minus 4x. That's minus 7x plus 6 equals natural log of x squared. Now, at this point, again, we have a natural log equals a natural log. We can use the one-to-one property to drop the natural log part and just say that's only true if 2x squared minus 7x plus 6 equals x squared. This is now a quadratic equation to solve, so subtract x squared to get it equal to 0. This one factors. I get 2 positive answers. I still need to check them. It could be that you get a positive answer, but when you plug it back into the natural log expression, you get a negative value. So take a look at 6. If I check 6, I get natural log of 4, that's fine. Natural log of 12 minus 3, fine. Natural log of 6, fine. But if I plug in 1, I get natural log of 1 minus 2. So it just has to mess up in one place, but it also doesn't work for this one. Natural log of 2 minus 3. 1 is okay on the other side, but you can't plug 1 into the side of the equation, so 1 is extraneous. 6 is the only answer. All right, number 5 again is multiple logarithms. So, and I have multiple on both sides. So we need to condense on this side and condense on this side. This time we're subtracting logarithms. So you can condense that into the natural log of x minus 1 divided by x plus 6. That equals the natural log of x minus 2 divided by x plus 3. It's natural log equals natural log, so you can drop the natural logs and just set their results equal to each other. That's the one-to-one property. And this is a rational equation to solve like we had last chapter, so we can cross multiply, clear out our fractions. And we've got some FOILing to do. And then you want to get this, I was going to say equal to 0, but the x squareds will cancel. So you want to get your x's on one side. So say I subtract 4x. And then I'll add 3 to the right side. I'm getting positive 9 over 2. And again, double check. 9 over 2 is 4.5, right? So you can just mentally check. Can I plug 4.5 into this? Yes. 4.5 into this, positive, yes. 4.5 minus 2, positive. 4.5 plus 3, positive. So we do get a solution. If I had to throw that out, then if I had like an x minus 5, then I would just have no solution for this problem. Okay, now number 6 has two logarithms, except it has this other number here. So I can't use a one-to-one property because I won't be able to get it to just log equals log. There'll always be a -1 or +1 somewhere. So instead, you're going to have the logs on the same side, which they are, condense them down into a single logarithm. This is the log base 1/3 of x squared plus x over x squared minus x equals -1. And I am noticing that I can factor out an x, but before I get there, I want to get rid of the logarithm. I can do that by saying I'm going to make this a base 1/3. So let me rewrite that so it doesn't look so weird. 1/3 to the log base 1/3 is going to cancel out of x squared plus x over x squared minus x equals 1/3 to the -1. So on the log side, making it base 1/3 just cancels this out. And then we can say x squared plus x over x squared minus x equals 1/3 to the -1 is just 3. And then we can solve this rational equation. I don't want to factor and simplify because if I cancel out a set of x's, I think I might lose a solution or a possible solution. Let's just see how this works out. So get this equal to 0, subtract x squared, subtract x, factor out a GCF. Oh, maybe it's okay. Okay, so I get x equals 0 and x equals 2. Had I factored back here, I wouldn't have the x equals 0 option because it would have simplified. 0 is not okay anyway. It's extraneous because you can't plug 0 back into here. You can plug 2. 4 plus 2 is fine. 4 minus 2 is fine. So 2 works, but 0 doesn't work. I guess when I'm solving equations, my safest bet is to not cancel out x's, just cancel out the fractions to begin with, and then you can factor out x's or whatever you would have divided by. All right, that's it for today. Let me know if you have questions with the homework.